All right, so today is April 23rd. This is our upstream working group meeting for the operator framework. And it looks like we've got a couple of things to talk about on our agenda. So let's see. First up, it looks like we have a brief that is in progress about supporting simple registry V1 bundles. Is anyone here to talk about that one? Let's see, is that Nikolai? That might be you that I just mentioned your brief. I don't know if you want to mention anything else about it other than the fact that it's present and needs review. And if you're talking, you're muted, Nikolai, so we can't hear you.
Sorry, I just joined a bit late. And what was that about?
Just
Is it
the
about the brief?
brief, yeah.
Right, yeah, it's just needs review. I got some feedback already. I will try to address it or respond tomorrow, but more eyes would be appreciated.
Okay, yep. Next up we have, so I think I added this last week or whenever it was that we did this, but I added a new epic in our 1.0.0 cut line above the cut line to make catalog D use encryption in its web server when it serves catalogs to clients. So Bryce, it looks like you added a comment here.
Yeah, last week I threw up a PR for it because it seemed pretty straightforward to enable TLS and throw together some cert manager stuff for like resources for self-signed certs. So that should have support for it. I just don't know what potential impacts there are to like using operator controller with it. Like if we're gonna have to update the cert store for the self-signed cert or whatever. But yeah.
Okay. Yeah. I think the hard part there is going to be I think everything on the cluster will be fine. It'll be if we want to do something in kubectl operator, getting that to work cleanly will be more interesting.
Yeah. Yeah, I actually wonder if because in the PR that I have up in kubectl operator for getting the client information, we do a very similar thing in the catalog D E to E tests that uses a proxy get. I think I had to update the port to 443, but it seemed to be able to handle that proxy get just fine.
What did we do in terms of the verifying the server cert?
Whatever client goes, proxy get does. So I don't know if it just ignores it or what. So I can look into that a little bit more. But.
Okay, yeah, cool. So that's not, I think that's something that we want to do for 1.0, but it's not on our, immediate working on this right now. But obviously, yeah, if you have free time, you're interested. We'll have to get to that eventually, or if anybody else wants to pitch in. Okay, anything else on that one, Bryce?
I don't think so.
Okay. Last week I spent a little bit of time trying to solve a few issues in OPM and the way that caching works. If you're not familiar, when we serve catalogs in a cluster, we run OPM serve for FBC catalogs. And there's sort of two modes that you can do that with. One mode, which is what we originally did, was just point it at the FBC root directory, and then on the fly, it essentially builds this cache such that it can efficiently serve the gRPC API without having to do a whole bunch of work every time to convert FBC to what the gRPC API expects. Originally, that's how it worked, and it turned out that building that cache takes tons and tons of time and memory. And Oh, okay, yeah. So it takes tons of time in memory. So the idea was, okay, well, let's just pre-build the cache, put it in the image, and then it's just there when we need it. And so that's been working for a while. There have been a few issues that cropped up around um, weirdness with the cache being considered out of date or somehow like wrong for the catalog that it goes with. So there's some code in OPM serve that basically says like, hey, let's make sure that the cache that's stored here is actually the right cache for this catalog. And for some reason, in some cases, it seems like our implementation of that check is a little bit too finicky and sometimes computes the incorrect digest for what should work, even though it doesn't. So I was looking at this a little bit last week, and I've got a few changes that I think should help. And I can try to demo it, although I'm looking at some numbers here, thinking like, yeah, this doesn't seem quite right for memory. But anyway, we'll go with it, and I'll show you what I've got and talk about what the intent is. And this is just a PR right now, but we'll see about whether we can merge it or not. So let me share my screen. One sec. Let's see. Okay. So I have an OPM binary that's built from the PR. And I also have an OPM master that's built from the current master branch, or at least a very recent one. And then I've got, this is the Red Hat operator index. I won't show anything sensitive here, but this, I think, exercises the changes a little bit better than if I use Operator Hub. But you can do OPM serve catalog, and then you can say cache only. So this is the new, let's do master first. Okay, so I'll explain this. Gtime, this is GNU time, which has a -b flag, which gives me a bunch of interesting information about this run of this command. This is the master version of OPM, and then we're just gonna essentially tell it like, hey, serve a catalog, build the cache on the fly, and then just stop after you've built the cache. And since we're not specifying cache here, it's gonna create a temporary directory, build the cache in it, and then delete the directory and exit essentially. So this is basically just like timing how long it takes to build the cache, and I'll get some other stats about memory and other things like that. So on master, this takes a little while. Okay, so it took 15 seconds, and it used 1.6 gig of memory at max. And so this is essentially why we couldn't do this anymore, right? So on master, this is what we used to do essentially, is we would just say, serve this thing and, do your thing and build the cache on the fly. Turns out that like at startup, it takes, almost, 1.5 gig of memory to build the cache. So that wasn't great. And so we switched to build the cache in the image, and then there's some issues with that. And in this PR, I'll show you there's some fixes there too. So the next thing, we can just switch over to this command, and I improved some logging here. So now this says like, hey, I noticed your cache directory was empty. I'm going to use your preferred backend. I've got this new backend implemented, which should improve the issues with the finickiness of the digest computation, and it is also a performance improvement, which I won't show today because that'll take too long, but I can talk about it at least. So this is still taking a little while, and I'll explain why that's happening.
Yeah, can you explain
Adam.
more about the back end and the digest computation, since we've had issues with that?
Yep. I'll get through this and then I'll go into some of those details. So this took the same amount of time, but it used like half the memory, and I'm pretty sure I can get this down even further. I'm actually surprised to see this number this high. This is still like 760 meg. I was fairly sure that I got it down much lower than this, but so I might have, I've been hacking on it this morning, so I might have introduced something that I shouldn't have. So two things. The second one is your question, Adam. So the first one is, how do we reduce this memory? So the way that it works on master is that we block the entire file-based catalog, load the entire thing into memory, and then build a model from that file-based catalog that's in memory. And that model also takes a lot of memory. And so we end up having like 2x the size of the entire catalog in memory in order to build the cache, which is not great. So one of the changes I made in this PR is let's not do that. Instead, let's walk the FBC router, and instead of building everything in memory all at once, let's just essentially like figure out where all of the blobs are for each package and build an index of that by package. And then we'll just iterate package by package, building a model and updating our cache just for that package. And then we can get rid of that memory and move on to the next package and keep moving, because every package can be handled in isolation. So that's the big improvement that takes it from 1.6 gigs down to, I think it should be a lot smaller than this. I added some concurrency stuff, which if you run things with concurrency, then now you can get like up to n number of packages in memory at the same time. So maybe that's what this is. But I was noticing that things get much better if you only do one package at a time. So that's one thing. And then Adam, your question. So there's a JSON backend, and that's what we currently support only right now on master. So if I would go back here so I can build a JSON cache. So we have the JSON cache that essentially like writes a digest to a file on disk, and then it also writes all of the API bundles as JSON and all of the package index, which we need to be able to compute some of the gRPC responses. So you see there's a digest here. And then in the cache directory, we have every single individual package name, channel, bundle, .json. So everything is serialized as JSON here for every single combination of package, channel, bundle. And that's sort of what this cache looks like. If we look at, this will be fairly opaque, but I can do the same thing. While this is running, I'll explain. So the way that we figure out the digest for this is we essentially just tar up the entire file-based catalog directory and the cache directory, and then write it to a digester, and then figure out what the digest of that combined thing is. And the tar implementation that we have for this essentially like zeroes out the username and timestamps so that, you know, those things don't apply to the digest. Essentially, you can have different usernames or different timestamps on files, and that won't affect the digest calculation. Unfortunately, one thing that we did not do is zero out or normalize the permissions. So one thing that affects the digest is if you copy a digest somewhere and the permissions change on the files, that will give you a different output. So that's my guess, is that that's the main reason that digests are having problems now, is that the permissions change on the files. And so that was one of the things I looked at for this new backend. So the way that I implemented this is essentially like, so if we run the new OPM against the old digest, it'll say, oh, I already found existing cache contents for the JSON backend, I'll use that. If you give it the new cache, it'll say, oh, I found that for this backend, right? So it has some logic in there that says, like, I know what each of the cache's contents look like. I've got a preference order for which one I want. And I can even do something like this, where I can say, so I can just stuff it all together. And then if I use that cache, it'll say, cool, I found the program cache stuff. So it has a preference order, the way that this PR is implemented, where it says, if I find the program stuff, then I'll use that. Otherwise, I'll use JSON. Otherwise, it's empty, and I'll use program because that's my preferred one. But the way that this one works, so program, you're probably not familiar because had just sort of discovered this last week, is essentially sort of like a bulk database, but it's geared more towards bulk load and heavy read load, which is pretty much what a catalog looks like. And so it's like a database. I'll show you what the files look like. So it's sort of opaque here, but it's sort of a key value store that you can store stuff in. So the way that this one works is when we compute the digest, we walk the file-based catalog like we did before, but instead of doing a tar of the entire thing, we just write the blobs themselves to a digest. So that way, like, the only thing that matters is the order that you write the blobs, and as long as the file-based catalog directory contents have the same structure in them, we'll always walk that structure in the same way. And so you can write all the blobs into the digester and you get the same digest for the FBC. And then on the cache side, we also want to make sure that the cache is included as part of this digest calculation. And so there we just walk all of the keys that are stored in the database and do that in a consistent ordered manner. And write all of the key value, like write the key, write the value, write the key, write the value for every single key that's in the database. And then that becomes our digest. And so now, like, we're not like the permissions on the file, like none of that is a thing anymore. It's based purely on the content of what's in the cache and what's in the FBC. So I think this will be a lot more robust and won't fail in weird cases where things are getting copied around. So two wins here, I think.
Few follow-up questions, Joe.
Yeah.
First one, so since we're dealing with ordering now, is there an issue when the situation happens where a version gets inserted in the middle, right? So say that 1.0.0 is in the catalog, 2.0.0 is in the catalog, and 1.5.0 gets inserted. Like as an update.
Like if something gets inserted, you've got to rebuild the cache anyway.
Okay.
So at that point you'll just recompute based on the new things that are inserted in the FBC, and then you'll have to rebuild the cache because you need the cache to have the new thing in it as well.
Okay. And then the second question is going back to the memory utilization and stuff like that. Since there's multiple things that, for lack of a better word, control the deployment of OPM and its size for the catalog, is there any other additional work that we have to do, like side stream, to change the deployment configurations for these along with your memory utilization changes?
So the way that, so there's two entry points essentially into, well, if you're talking about catalog sources.
Yeah, just like catalog sources, and like they're controlled by other entities, right? So like other things control their deployment on cluster, which controls their size and CPU and memory utilization. Is there anything that has to
Yeah,
be
so I
considered
think
in those configurations?
yeah, so there's if folks are using catalog source, um, there's two ways that you can use an FBC. One is with well, really you have to well, I could be wrong about this, but in general, the only way I've ever used it with FBC is by specifying an image, right? And then there's sort of two modes that you can use when you specify an image. One is just use the binary that's like just run the image directly. That's sort of the old way. And then there's a new way that we introduced recently, which is extract the contents of the catalog in the cache directory, and then use the OPM that the on-cluster OLM wants to use. And so the preferred way from the OLM team's perspective is the latter one, which means that we essentially can always make sure that the latest and greatest bug fixes are running for your FBCs, and we can essentially, like, no matter what is in the catalog image, make sure that you're using an OPM that we think will be that'll cover like everything and have all the latest bug fixes in it. And then that means that we can also make some changes to optimize how, like this optimization, if you built your catalog image and didn't run it with this extract content mode, like you would not get this feature for free. And so the idea is like, if we can build these features into an OPM image and then use that image when we launch OLM, whenever it manages catalog sources, then we can make these sorts of improvements without catalog images having to change at all. And so that mode is basically like we can make like if we merge this change and then get that into a release of OPM, then from then on, anything that uses the extract content mode of the catalog source will pick up this stuff for free. So in the past, it might have been maybe it's already defining things that way. And now it's like it had to include a cache in the image. And so like their thing will keep working because we'll just pick up the cache that's there, and memory is already taken care of because the cache is already built. We can skip right past the heavy memory usage part and move on straight to serving. So like existing images that have caches built into them, all good, like nothing changes. For the teams that are having problems getting the cache stuff to be consistent and work, this change would mean just stop building the cache, probably. Like you don't even need it if we can get the memory utilization low enough for the cache build. And then in that case, on the fly, the cache will be built when the catalog source pod starts up. And it might take a few more seconds to have it start to serve. But other than that, like you won't really notice a problem. One other thing I should show, actually, and this is I went too far. So I have two versions of the catalog here. So there's the catalog, which is literally just straight out of the image, and then there's catalog migrated, which is using the latest and greatest FBC output format, essentially. And I'll tell you exactly what the difference is. So you've probably heard us talk about this a little bit, but when we originally released FBC, we had this olm.bundle.object. You've probably seen this. It's a huge wall of text of JSON, base64 encoded JSON of all of the objects that are in the bundle. Those are huge. So if we look at the relative size of these things, so what, almost 90% smaller, just replacing these olm.bundle.objects with this new olm.csv.metadata. If we OPM serve this and build the cache, you can see that was much faster, just barely almost 3 seconds, less than 200 meg. So that, I think this is like where I want things to be, right? Like, I think we can get to the point where you don't have to put a cache in the image. You've already done your migration, so you're using the olm.csv.metadata, and startup is, 2.8 seconds longer than it would be if you pre-built the cache, and basically uses not really that much more memory than if you were gonna, do a list bundles call or, anything else. So the peak memory usage never really gets much beyond the steady state. Yeah, Jordan.
So where we ran into this problem previously, I mean, it's good that you're looking at memory, but where we ran into problems previously was the duration and magnitude of CPU allocations on alternate architectures. So like it was the, what, 390X, I think, is where they were running into 17 or 22-second delays getting the
Yep.
thing ready because of that and blowing their CPU allocation. Have
Yeah.
you tested any of this on alternate architectures just so that we have a good comfort level?
Not on alternate architectures, although I think we fixed that problem. Well, I think we worked around that problem by introducing the startup probe. So that's in there now. So now in theory, the whatever the health checks or liveness checks that were running before that were failing due to the startup time taking a while, like that's not an issue anymore. It is still an issue that, building the cache still takes the same amount of CPU overall, because we still have to essentially do all of the same things again. But I will note, I guess, that using the pogroup stuff, it uses protocol buffers instead of, like, it serializes as protocol buffers instead of JSON. So that takes less CPU because it's a tidier format. It's all binary. And then that also translates to faster serving time and lower CPU and memory usage when it serves as well, because it doesn't have to deserialize as JSON and then reserialize as protocol buffers when it wants to do a list bundles call or whatever. So that I did some manual testing using a GHZ, which is sort of like a gRPC curl, except as like a thing that throws 200 connections and 20 clients or whatever at it. So that was a lot better from the serve side. But no, to answer your question, I have not looked at other architectures. I would expect that between the startup probe fix that we made a couple releases back and switching to catalog migrated, if we can get pipelines building with the newer versions of OPM and using this new cache backend, like that trifecta of things will make things basically, you won't even really notice that a cache is being built on the fly.
Okay, so I came in late, apologies. I did not, so you are suggesting that we no longer have to enforce that cache is already pre-generated in the image, that we could actually generate it on the fly with the new approach?
I think so. I think it might,
Okay.
in my mind, I think it might require, like, I would suggest probably like only do this with catalog images that are migrated. Because you can see here the max memory that we use in that case is 170 meg. And you missed at the beginning when I ran this same thing on use OPM master against an unmigrated catalog, it was 1.6 gig. So we're like a 90% decrease in peak memory usage by like these two things switching.
Oh, that's huge. Okay, yes, thank you, I did miss that.
And it was like 30 seconds of wall clock time versus 3. So again, like 90% decrease in CPU as well.
Yeah, so I think that defangs the monster sufficiently that at least I have good confidence now. Thank you.
And even, yeah, and so I think what I would suggest is we should probably try to merge this. We can do some reviews and make sure that I, am not being stupid in some way. And let's not initially recommend like everyone can just drop your caches now. Like we can get this merged. We can make sure that all of this is still working the same way that it always has, and it's backwards compatible, yada, yada, yada. And then once we get comfortable with how all of this works, then we can go and start looking into like, well, yeah, could we go and just get rid of the caches, and what does that look like from the catalog source perspective and that kind of thing. The last thing I would say here is none of this matters that much for OLMV1 because we're not going to serve gRPC APIs and we don't need a cache at that point. So there's a half-life to this that isn't too long. So it might not be super important either. Like we've already got things kind of generally working. And so there's a reasonable question that I think you could ask, like, is it worth it to make this change and to try to roll it out and to get people understanding what it is and all of that kind of stuff. So I think that's part of the equation here. Okay, any other questions on that one? All right. Well, sorry that turned from a quick demo into a 30-minute demo. So hopefully that wasn't a waste of time for people. Last thing is just our roadmap check-in. I think we talked about this. Share the screen.
Yeah. So last week we talked about updating the milestone check-in, the individual milestone check-in to a more general roadmap check-in. So I did that right before this call. So this should map, to this roadmap, and we can kind of just go over that. I don't know if we also want to, as part of this, go through like the epics that are currently in progress and have like little status updates on them or not, but I figured
Yeah,
we
let's
could
do
kind of
it.
iron that
If
out.
folks are not put on the spot too much. So Bryce, speaking of that, you've got one over here in progress.
Yeah, so the operator controller supports safe security upgrades. If you go into the breakdown tab to the right of V1 epics, that should show like a clean list of things that are in progress and done. I just started working on adding a check for handling updates to existing fields to decrease the minimums, so that should go to in progress now. And I'll assign myself,
I can do it.
or you can do it for me real quick. And so I think some of the most recent ones that were merged were in the done section. And by merged, I mean up in CAP, the library we've been writing up there. 716, I think 666, it looks like. And then I think there was one that Rashmi had done, I think 664. That those have all merged recently up in CAP. Rashmi, is there any ones that if you're in the call, is there any that you know that I'm missing by chance? No. So those are the things that have been done recently. The ones that are in progress, the top one, 663, should have a PR up. I think Ish is planning to work on the testing for that to get up to speed. But other than that, yeah, I think we're in a good state moving forward. I think that as we've been implementing some of these general field change validations, so like whenever you update a field in a CRD schema, there's a couple more checks that I'm noticing that like we might need to add things like if you change the default value, handling of changes to union types like any of, one of, we could probably do a little bit of validation there. So probably planning on creating a couple more of those tickets. I think probably need to have a little bit more discussion around the plumbing in operator controller, since we're no longer going to be building on top of cap. And kind of see what that's going to look like. There was some conversation between Rashmi, Ish, and I around like some potential paths forward for that. But I'd like to get some of your input on that, Joe. And if we have some time, we can come back around to it today, like during this meeting. But I don't want to take up too much time for other folks that are interested in doing status updates or something.
Yeah, it sounds good. One thought that I had as you were walking through adding some of the stuff here, sounds great. Let's get some stuff written down. I think there's a separate discussion of like, well, how much do we want to do for this relative to some of the other 1.0.0 features that are completely separate, right? Like, do we want to say like, well, this is enough for now. Let's move on to some of the other 1.0.0 blockers. And pick this up later, right? So I think we need to figure out like what really are the bare minimum set of checks and then stop when we get there and move on.
Yep, I think that that's reasonable too. In my head, those two seemed probably pretty good minimums. I don't know that there's much more after that. I think that any of and maybe one of could probably come later, but I think the default one is probably a pretty low hanging fruit that is a pretty good one to have right out the gate.
Yeah, I think so. Okay, thanks, Bryce. Let's see, we have, okay, so this one, I don't know if I've mentioned this yet, but at least in this group, but I pulled this one up myself and took a stab at it. It was actually fairly straightforward, just a single PR. The explanation behind this is we want to make sure that when we release OLM 1.0.0, that we actually honor the upgrade edges that are in the existing catalogs. And the way that we had been approaching upgrade edges before, there were two ways that we handled it. By default, we were using a feature gate that we turned on called like force simver semantics. And that meant that we actually were just ignoring skips, replaces, and skip range in the catalogs for OLMB1. And we were just saying like, we'll just do simver instead. And that was good for when we were trying to sort of design how we wanted to build an extensible API for how to handle upgrades. But in terms of what we want to do for an initial release, we want to make sure that we actually honor what the catalog says. So we turned that feature gate off. And then, so that happened in this PR. And then another thing that happened in this PR is when we turned the feature gate off, the only upgrade edge we actually supported was replaces. And so there were other upgrades that would not have happened even if the catalog said them because they were skips or skip range upgrades. And so this PR also went in and added the checks for, is this something that, do I skip this thing or do I skip range this thing that's installed? And if so, then I'm also a candidate for upgrade. So with this merge now, we're back to the legacy successor implementation and it supports both skips and skip range as well. So I think that epic is pretty much done. I made a docs issue. Michael, yeah, you're here, Michael. So I tagged you on this at some point, but it's not super high priority. This is whenever we get to it. But I wanted to try to make sure. So I used your template. So let me know. Okay, I saw you saw that already, so that's good. So yeah, I think that's it for that epic. Michael, any chance you have any update on docs? If not, and you say no, that's totally fine. But what give you the chance?
Yeah, I started reading up on the V0 doc, and I hadn't gotten to with the KubeCon push for docs. I didn't get to the skip or the Semver stuff yet, so I still need to kind of port the downstream doc. So I'm still kind of scoping out that work and trying to find time to do it. So I'm hoping that I'll have like a draft PR next week.
Okay, yeah, and just to make double clear, you might see some stuff in for, in the more recent release, I guess this is probably unreleased. So if you see docs about how to do successors and upgrade edges that talk about Simber, that's no longer the case. So there's still code in there that handles it, but we've disabled the feature gate and things are back to sort of the OLM v0 way of doing things.
Oh, okay. Okay. Yeah, I'll look over the PR and everything, and if I need help, I'll just put like a half hour on your calendar or something like that, or bring it up.
Perfect. Okay, sounds good. What else did we have here? Oops. Okay, so we also have a few other things I know that are in progress, but we're also sort of doing some prototypes and designs at the same time. So I don't know, Varsha, you want to talk about yours at all?
Yeah, sure. So for the cluster extension controller embedding Helm, we have a separate branch called Helm POC in our operator controller repository, where Todd and I have been working on getting things POC'd in terms of merging the Ruckpack code and trying to do things. For now, the progress is we have all the necessary Ruckpack side of code in terms of unpacking, converting, embedding into a single controller already merged. Right now we are working on building and being able to run and testing a registry v1 plain bundle. So we are in good progress for that particular POC.
Awesome. Any questions there from anyone? All right, moving on. So Nikolai, you're working on the simple registry v1 bundle support.
Mikolai had to drop, but I can speak to some extent on this. We just have the brief open for review on this.
Yep. Okay, so we talked about that at the beginning. I know Mikolai was talking about, maybe it's in the brief, some implementation details of like where to do this. And it seemed like the consensus was that Ruckpack already checks for registry v1 bundles with no webhooks and for all namespaces mode. And so the only extra thing that was in this was no dependencies. And so we were thinking we would add that in operator controller where we already have access to the bundle metadata and can check to see if there are any dependencies declared. And if there are, then we reject at that point.
Yeah, we have some back and forth in the docs because it looks like there may be some additional places where we can access the metadata in the CSV, but also whether or not we have a complete mapping of all of the v0 supported dependency types. And I think where we landed on that is pretty much, it's sufficient for this doc if we just say, hey, what we're really adding here is to reject for any kind of identified dependency. And then we'll RFC in more detail what the mapping looks like to verify that we're covering all of the v0 representations of those dependencies.
Yep. Yeah, I think that works. In my head, it was going to be just these two that Nikolai mentioned here. We could do an audit of catalogs to see if anybody else is using any of the other more esoteric property types for constraints that never really gained any traction. I would assume that no one is using those and it's probably safe to ignore them. But that's me making an assumption. So we should at least double check on that.
Yeah, and that's largely why the conversation went to RFCs, because we're like at a high level we agree.
Yeah.
And it's the details that we want to bang out that are implementation related that we could just do in that other doc.
Yep. Totally agree. Varsha, you got your hand up?
Yeah, I'm sorry I missed the initial part of the meeting, but my question here is the first two checks happen after the unpacking. So the third check in terms of dependencies, are we referring to after the unpacking happens, or is there any way to figure that out from the catalog metadata for the
So
particular funnel?
yeah, so the checking for webhooks has to happen after unpacking because that's the only place we are guaranteed to see the full CSV.
Mm-hmm.
Checking for all namespaces mode, maybe we could do before unpacking, but I think it's still better to do it after because again, that's the only place that we are guaranteed to see the CSV. Dependencies, we can see that in both places. Dependencies have to be in the catalog for us to be able to ever done dependency resolution. So it's reasonable for us to say that we can do that before unpacking. Obviously, they're also in the bundle image, so we could also parse them out of there if we wanted to consolidate all into one spot. I think Nikolai and I had a conversation around philosophically where we should put this check. And the thinking was if we do it only from the catalog perspective, like it's thinking about like how yum install versus RPM install works. Like yum install considers dependencies because you have a repository there that has dependencies that you can use. If you do RPM install, like you have to like you can basically like install without dependencies. And I guess you could do that with yum too, but like installing a direct bundle, the implication is that like you're not going to do dependency management anyway. And so maybe we do allow something like if we get to the point where we're supporting direct bundle installations, maybe we let that bundle be installed even though it specifies dependencies because there is no expectation that we would ever honor those dependencies on a direct bundle install mode. And so like that was the reason that I think we sort of moved towards let's put this during the sort of the catalog resolution time rather than after unpack time. But we can revisit that. Like that's not a set in stone thing.
Yeah, that sounds good. I just wanted to check where would this be plugged in the whole code. So yeah, thanks.
Yep. Okay. Lance, are you here? I don't see Lance. Let's see. Do we have Ankita or Daniel? Ankita, any chance you want to talk about the work that you're doing on this particular epic? Or if you've started yet, I'm not trying to put you on the spot. So if you don't know what this is, I can certainly take it too. And you're muted. There you go.
Yeah. I haven't yet started on that yet, so I don't have anything to report as of now. But I am planning to get started on that today, so there's that.
Okay, yeah. I know that a few things have started. I think I saw Nikolai remove some Deppy stuff, so that's part of this. The other part, so maybe I should back up. So this epic is mainly about taking the more recent work that we've been doing in the extension API and porting it back over to the cluster extension reconciler. The reason that hadn't been happening before is because, a month ago we were thinking we'll just have a single namespace scoped extension API, and that'll cover all the possible use cases. But after the team got together for a face-to-face and talked through a lot of the details of all of this stuff, we decided it made a lot more sense to keep the cluster extension API for the things that are cluster scoped. And so this epic is basically like, great, like we've made a lot of progress on the extension reconciler. Let's do that same sort of thing in the cluster extension. So as far as I know, most of that work that we were trying to wrap up the extension side has now merged. And some of it now has started to trickle back over into the cluster extension controller. So that's what this epic is. The main two things are updating our condition logic to define a set of conditions that seem like they make sense for the direction we're headed, and then B, try to update them in a way that makes sense from like sort of a dependency standpoint, right? Like you can theoretically compute the status of an installed bundle just by checking to see if that bundle is installed and doing, your normal install checks on it. You don't necessarily have to resolve from the catalog. Or you can check whether your specified package and channel are deprecated without, successfully doing a bundle installation. So there's things like that where we can clean up and essentially like have our status conditions updated in isolation of each other a little bit more than we do now. And then the second step is because of the decision that multi-tenancy is not something that we can handle in a first-class way, and because we don't want to manage dependencies automatically anymore, we're planning to just fully remove dependency management from OLM v1. And so we no longer need a SAT solver because a SAT solver is the thing that solved a lot of problems around like handling dependency trees and like really complex dependency graphs. Now, without that requirement, we can just essentially filter what we get from the catalog. So we'll basically say like, hey, give me all the metadata for this package from the catalog, and then look at the spec of my cluster extension to see how to filter it down to the things that the spec says I should accept. And then also look at the, like, is there an installed bundle, and filter it more based on what the upgrade edges are. And it all just becomes just a filtering problem rather than a SAT problem. So part of this epic is to remove the SAT solver and essentially simplify how resolution works for a cluster extension. Any questions on that one? Or other comments? All right. A few other things that I can quickly touch on. So I've been trying to get ahead of these things and look at some of the future things. So real quickly, I can go down this list of stuff that's still in the backlog. I haven't looked at this one yet, but the plan for removing the extension API is essentially for our 1.0.0. We're just not going to have an extension API. We can always add that later. So we're gonna remove it from the main branch so that we can focus purely on getting the cluster extension stuff done and not be bogged down by code sharing and keeping things dry and that kind of stuff. So we'll just remove that so that it doesn't become a distraction and something that causes PRs to stay open longer than they need to. We want to have a really strong guarantee on making sure that no two cluster extensions can manage the same object. So this is sort of like, we don't want to have a case where you can have two cluster extensions that own the same CRD, and then you have race conditions about which cluster extension owns the CRD and whether they flip-flop back and forth. So we want to eliminate that. And so the plan is that we'll use a new feature that's coming in Kubernetes 1.30 called validating admission policy, which is essentially a much, much nicer way of implementing fairly arbitrary admission logic, but without having to implement a webhook. So I've done a little bit of exploration in terms of how this would work in the context of Ruckpack, put together the policy and a binding for it. And we should be able to translate this fairly easily over to the new implementation in the cluster extension that Varsha is working on. And Ruckpack won't be a thing anymore. So some of these things will have to change based on the new labels that we use and the new types that we use. But for the most part, it seems like this should be implementable with some minor changes. Another thing that we're planning to do is use a service account in the spec to manage the content rather than give OLM v1 cluster admin. So I started looking at this a little bit, and again, like in the context of Ruckpack, because that's the thing that currently manages bundle deployments. It looks like this is fairly doable. So there's a few things that I did here. So one is in the Helm operator plugins repo. There's a PR up that I basically made some changes to make it possible to allow a service account to be passed into Helm operator plugins to be used as the thing that provides the REST configuration, which is how you get the bearer token essentially to use for the server. So this change is necessary for us to be able to, on a per object basis, use a different REST configuration because every object is going to potentially have a different service account. This change reverted some changes that were implemented to fix a memory leak. So I went and asked the ACS folks if they could take a look and make sure that I didn't reintroduce the memory leak, and they just got back to me today and said, "Oh, everything looks good." So Varsha, I tagged you on this in Slack. I don't know if you saw it yet, but if you wouldn't mind giving this a review, we can go ahead and get this one merged.
Yeah, sure. I'll take. Thanks, Joe.
All right, thanks. So that's sort of part one, and then there's this PR is open in Ruckpack that makes use of that change in Helm operator plugins. And then the other thing that I changed, and we can talk about how we want to do this, but this is probably a little later, and we don't have to necessarily focus on this one right now, but to do health checking, the way that we currently did things in Ruckpack is that we would use, like, separately from the Helm client, we would use the service account of the bundle deployment controller. And so to get it to use the Helm client's service account, I went and changed the action client interface to add a new check health function. And then I went and implemented that for the default action client. And so this is basically just a copy and paste of the code that we already had in Ruckpack, but it's now just added into Helm operator plugins, and we can call it. And by calling it via this action client, this is the client that has it's already set up with the service account attached to the cluster extension or to the bundle deployment. And so you get all of this health checking done in the context of that service account rather than in the context of the controller, which is necessary if we don't want to give our controller read access to everything. So I think we'll need that eventually too. Moving on. So that, I think both of those, I think the first thing is required for us to do the service account stuff. The second thing is required if we want to do the health checking. But the health checking stuff, I think, is below. It's in like the 1.0 or the 1.x stuff here. So if we don't get that ported over for 1.0, I don't think that part of it is that big of a deal. We talked about, we haven't talked about this one yet. So quickly, if we haven't talked about this and folks aren't aware, in OLM v0, there's an operator conditions API. The way it works in OLM v0 is that OLM itself creates an operator conditions object on behalf of every single operator that it installs, and then it injects an environment variable into the deployment that can tell that deployment where to find that operator conditions object. And it creates RBAC permissions for it to be able to update and be able to find that object, right? So OLM is doing a bunch on behalf of the operator to set things up with operator conditions. The implication is that there are very likely operators in the catalog that require operator conditions to work in a certain way, but we have no visibility into which operators those are because there's no metadata that we have that says, hey, I need this API to exist, because OLM sets it all up for all of the operators. And so the conclusion that we drew is, well, okay, because we don't have any visibility, we can't do a thing similar to the filtering that we were doing in Nikolai's epic. Like in this epic, we can look at the catalog and look at the bundle and say like, oh, we can't support you because you're not, you use webhooks or you're not all namespaces mode. If there was metadata that said we need cluster operators, what we'd probably do here is we would just say like, well, we don't support you because you say you need cluster, or what was it called? Operator conditions. So because there's no metadata, the idea is that in order to GA, we pretty much need to put some features in that honor the same API for registry v1 bundles. So this epic is just about setting that stuff up in the same way. We haven't designed this yet, really, other than the fact that we think we need it. And one of the open questions, I think, is like, do we need to, like, how far do we need to go for this? Do we just need to set things up and make sure that the operator can write to it? Or do we also need to consider like the reason that the operator wrote to this API is so that it could inform OLM v0 of the fact that it didn't want to be upgraded at that time. And so part of the question, I think, is should we honor, like, should OLM v1 honor an operator saying that it's not upgradable right now? And so I think we need to answer that question. My hunch is that we probably should. Like, if we're going to go to the trouble of setting all of this up, then it would be a little bit weird for us not to look at that and also honor like upgradable false and not do an upgrade. Which hopefully isn't that bad because we have some other code that already like filters based on what's currently installed and decides what the upgrade targets are. So if we put this in as input into that function, then it's just like this would basically say like there are no successors right now because the upgrade is, blocked. But yeah, so that's the scope of this epic. And then that's pretty much the extent of features for OLM v 1.0.0. The last two things here are just getting some API reviews for catalog D and operator controller and making sure that they're at a state where we are comfortable GAing them and saying that we'll support the shape of that API, into the future. So we want to do that before we GA, obviously, because if we make a mistake, it's much harder to take it back after we've released a GA version of this thing. And I realize we're 5 minutes over, so unless there's anything urgent, we can call it here. All right, well, thanks for going over, or thanks for coming. I'm sorry that I went over. We'll see everybody next week.
Thanks, Joe.